All right, take out your notes, and we are heading into this last part of our pre-work before we tackle Module 8. And we're going to call this 8.04. We're going to talk about scale drawing, scale models, scale factor, all those things. I need you to scribble out where it says textbook pages and what your assignment is, mainly because this is from the old book and we forgot to delete it. So just take that out of there. There are a lot of words that have to do with scale on here. Look at your vocab list. All of these things are part of today's lesson. And basically what you're going to do in your learning target is we are going to find and make comparisons between an actual item and either a scale drawing, a scale model, or some kind of representation that's not the same size, and look at the comparison of those dimensions. Alrighty, so let's start first with scale drawing. I know it's bad to use the word in the definition, but a scale drawing is a drawing, okay? And it's a drawing of some sort of object or, oops, put a C in there, object, thing, a place, something like that. It could be a map, it could be all kinds of things, okay? And what happens here in this drawing, it uses scale to make the drawing, so I'm just going to say to make it bigger or smaller from the original. So bigger or smaller. Sorry, I know there's an awful lot to squish in here and I write really big, okay? To make it bigger or smaller than the real thing. Let's move on to scale. Scale is a ratio that compares to quantities, okay? And it's a ratio of the measure or the measurements, okay, between two things. For example, and you're going to see it down here, right here in scale, where it says 1 to 20, 1 centimeter, 1 meter. That's what it looks like. So I'm just going to draw a little arrow that goes right down there. A scale model is some sort of three-dimensional object or three-dimensional thing, or I guess we could say model, all right, that is proportional to the real thing. It's proportional to the real item. Toys are a great example of this, whether you have Matchbox cars or Tonka trucks or dolls or furniture, a dollhouse. Gosh, there are just tons of things toy-wise that represent scale models completely. Reductions and enlargements have to do with some sort of scale, so it's a numerical way of measuring things, and it's some sort of scale that we use, and it's going to make a scale that makes something, and if it's a reduction, it's going to make the item smaller, like a shrinking machine. If we have an enlargement, it's some sort of scale. Now I'm putting ditto marks here. Scale that makes something larger. So let's take a look at some examples of some scale. 1 to 20. That means if you see the scale on something, like on a map or something, 1 unit on the drawing is equivalent to 20 units in real life. If they use different units, they'll specify the units. Notice here they didn't have units, so if it was inches, it's inches, feet to feet, miles to miles, that sort of thing. But when they have specific labels, then make sure you include that when you set up a proportion. 1 centimeter on a drawing is the equivalent to 1 meter in real life. Also, this one, inches and feet, since we live in America, course, we can't use the metric system here. No, no, no. So this comes in handy, and you can set up a proportion every single time. The length of an object on a scale drawing is 2 centimeters. So we've got some sort of object thing here, and it's 2 centimeters. And the actual length of the real thing would be 8 meters. So the scale looks like this. 2 centimeters on the drawing represents real 8 meters. So usually we set up a proportion like this. 2 centimeters, this is on the drawing, is to 8 meters on the real thing. Let's set that up to figure out when it says what is the scale, they've kind of got it set up here for you. That means 1 centimeter represents what? And you might be able to see this directly in your head. Otherwise, cross multiply and solve this one. Say 2 times x has to equal 8 times 1. And then divide both sides by 2, and you should get good old 4 there. So right here, 1 centimeter to 4 meters, that's the scale. The scale always starts with a 1 as the first item, or a 1 in the numerator over here. All right, let's try some more of all these different applications of scale, scale factor, scale model. The length of an object on a scale drawing is 4 centimeters. The actual length is 12 meters. The scale is 1 centimeter to what? Figure it out. So 4 centimeters on the drawing, and sometimes I just put this here, and here's the real. 12 meters in real life. What is the scale? I'm asking you 1 centimeter represents what there in meters? Go ahead, cross multiply. Some of you might be able to see this if you can see it, or if you're solving it another way. Boom, just show me what you're thinking and give me your final answer. When I divide both sides by 4, I get x is 3. So the scale is 1 centimeter to 3 meters. Boom. Ooh, here's a good one that's kind of going in the other direction. Think of in science class when you look at things under a microscope. It says under a 1,000 to 1 microscope view. 1,000 to 1. I'm going to write my first ratio on the left side this way. The 1,000 is the amplified big picture that you are seeing through the lens. So this is under the microscope. This is how big it looks, but in reality, the real thing is probably pretty small. Duh, that's why you're using a microscope. It says an amoeba appears to have a length of 8 millimeters. That means under the microscope, it looks like it seems to have a length of 8 millimeters. What is the actual length? That goes down here. So go ahead and cross multiply and solve this one. 1,000 times x equals 1 times 8, which is just 8. Divide in order to isolate your variable x. 1,000 divided by 1,000 is 1. And you get 8 thousandths, or in other words, as a decimal, 0.008. That's 8 thousandths. So what is the actual length? The length is 8 thousandths of a millimeter. Holy cow, that's tiny. No wonder we're using a microscope. Next one. A model of a 27-foot house was made using a scale of 2 inches is to 3 feet. 2 inches is to 3 feet. Inches to feet must equal inches to feet. The real house is 27 feet tall. What is the height of the model? Boom, there we go. Go ahead and use your cross products for the proportion. 2 times 27 has to equal 3 times x. Isolate your variable. Boom, 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 boom. I don't know why I multiplied 2 times 27. That's usually not how I go about it. Divide by 3, and you should get x equals 18. What is the height of the model? That number goes here, and my label is inches. Whew. Okay, we're on a roll now. A model of a 24-foot tall bridge was made using a scale of 4 inches to 2 feet. Inches to feet. 24 is the actual height of the feet, or 24 feet tall. You find the model height in inches. Cross multiply and solve. 4 times 24 equals 2 times x. Isolate your variable. Let's see, 2 can go into 24 12 times. 4 times 12. I get x equals 48. 48 inches. That's the height of the model. That's pretty tall. That's 4 feet. That's a stinking big one. Holy cow. What is the scale of a drawing? Oh, what is the scale? Okay. In which a 9-foot wall is 6 centimeters long. All right, so let's talk about this. The drawing clearly is the smaller unit, 6 centimeters, and usually we work this way. Drawing to the real item. So 6 centimeters in the drawing represents a 9-foot wall in real life. You are trying to calculate what 1 centimeter represents in feet. All right, this is what your scale will be. So let's cross multiply and solve. 6 times x equals 9 times 1. Divide both sides by 6. Boom, boom. You get x is equal to 1.5, or 1.5. So don't just say 1.5, I'm done. You need to write the scale, and the scale always has 2 parts. 1 centimeter, put the colon, translates or represents how many feet? 1.5 feet in the real item. That's your scale. Next one, here's my scale, a 1/4 inch to 1 foot scale. How long would a drawing of 22 feet of a 22-foot car be? So 1/4 of an inch is to 1 foot. How many inches to how many feet? 22-foot car. I'm looking for the inches. Here we go. Cross multiply. Oh, I like this one. You know why? Because I'm going to take 1/4 times 22, and that equals 1 times x. I don't even have to divide. Hot diggity. Go ahead and calculate what's 1/4 of 22. 1/4 of something is just taking half and taking half again. Half of 22 is 11. Half of 11 should be 5.5. So how long would the drawing of that car be? It would be 5.5 inches. Make sure you label your answers on all of these. The very last one. The height of a person on a scale drawing is 4.5 inches. The scale is 1 to 16. Now on this one, there are no units. 1 to 16. Typically, the top number is the drawing or the model, and the bottom number is what the real object or item is. So if the drawing is 4.5 inches, then this value down here is the unknown, and it will be in the same unit inches. Our scale didn't have any. Cross multiply and solve. Oh, I like this again because I get 1 times x. 16 times 4.5. All right, go from there and you should get 72. That means the person's actual height is 72 inches. Now, if that doesn't make sense, usually we measure people in feet Convert that into feet by dividing by 12, and that is 6 feet tall. Check Schoology for your assignment for tomorrow, and as always, may the force be with you.